All right. Ah, that's so nice today. It was so quiet yesterday. Okay, hi everyone. We are about to start our mission spotlight over here at the Redwire booth. My name is Camille Bergen. I am a science communicator, otherwise known as Galactic Gal, and I have the pleasure of being your host for all of Redwire's events. Today, we are joined by Al Tadros, Redwire's CTO, and Mike Provenzano, new VP of Advanced Development Programs. Did I get that right? Yes, at Astrobotic. And they're going to be talking to us about Astrobotic's Luna Grid Lights, which I think you can see there. So without further ado, I'll hand it over to you.
Okay, thank you very much and welcome everyone. Excited to be here today to talk about everything about the moon. That's what we're talking about. So I'm here with Mike. I'm going to start out by having him tell us a little bit about Astrobotic and what you guys are doing, how you came about, because I think you're a very purpose-built company for the moon. And then we'll talk a little bit more about the specifics of what their landers and activities are, including a show and tell that Mike has here. So Mike, why don't you start and just give us an overview of the company and what activities you're doing?
Thanks very much, Al. Very happy to be here. Thank you, Redwire, for hosting this. So yeah, I'll just share a little bit more about Astrobotic, what we do. I think at some point we'll have slides up there, but in a nutshell, we provide lunar delivery services to the moon and on the moon, as well as other lunar logistics services, so power services as well. So right now, we just recently completed our Peregrine Mission 1 earlier this year. And unfortunately, it was not the outcome that we were hoping for, but we're really proud of the team for getting to where we did. We operated the spacecraft for 10 days in space. We flew out to cislunar distance and came back. And now we're taking all of those lessons learned and we're putting those into our next mission, our Griffin Mission 1, which is using our Griffin lander to deliver the Viper rover to the moon, as well as a few other payloads. We have NASA's retroreflector on board. We have ESA's Landcam X. And then we also just recently announced 2 days ago that we have a rover on board with the Canadian Space Agency. So very excited for all that. In addition to our lander delivery services, we're working on rovers. So we have a few rovers that we're operating right now, and one of which is going to be carrying the Canadian Space Agency payload. The other one is going to be supporting a lunar power grid demo. And that's something that we're very interested in. Lunar power is something we believe is one of the core infrastructure pieces of going to the moon and staying on the moon. And then in addition to power and rover services, some other things that we're working on are suborbital test flights. So we have a team out in Mojave, California that operates what we call our Zodiac and Zogdor launch vehicles. And we use those for recurring suborbital test flights. They have a lot of other applications as well, which we will get into some of those soon. So with that said, I think we could go ahead and maybe start the presentation, or we'll go next.
Sure. So we're going to talk about the power grid that Mike referenced, but is the presentation queued up?
I think so.
Okay, go ahead.
Thank you. Okay, so this was the mission that we just recently announced. You can see that's our small rover called Cube Rover. It's also the little baby that's sitting next to me right here. This is an engineering model that we're using, and we had to take it from our engineering team. They weren't very happy about that, but we have it here, and we wanted to show it to you all. It's going to be carrying a software payload on board, and then we're also going to be communicating over long distance on the lunar surface. So one of the things to enable sustainable operations on the lunar surface is long distance comms. So we could do several kilometers distance, communicate with a satellite in lunar orbit, or communicate with another lunar lander. We're also going to be testing capabilities like surviving the lunar night. So in this mission, we're not surviving the lunar night, but we are going to be collecting thermal data that will help us better understand how the rover performs in that environment in shadowed regions so that we can prepare for long-term missions. So now jumping into the power stuff. So one thing that we've been very excited about, what we've been working with Redwire on, is developing our VSAT, which stands for Vertical Solar Array Technology. It's a very tall solar array. Redwire has a lot of experience in this area. They've been deploying ROSAs on the International Space Station. We wanted to partner with Redwire because of their experience in that area, and now we're bringing it to the moon. So one of the cool things that we're doing is we're going to put this on a mobile platform, very big rover, pretty much the size of an SUV, drive it around, park it, and then deploy the solar array up. And that's going to allow us to generate power at different locations, connect power through whether it's cables or wireless chargers, so that we can provide power as a service to groups that would require that on the moon. So you can think about rovers, you can think about the Artemis missions, like the Lunar Terrain Vehicle, you can think about astronauts or human habitats. Everything needs power. And ultimately, right now, a lot of the spacecraft have to bring their own power systems with them. So you have to bring your own solar arrays, you have to bring your own batteries. And in this case, if we have a centralized place where you can just get your power and go fill it up like a gas station, it makes it a lot easier for groups to engage with that.
So how many people here have an electric car? Raise your hand. Electric cars? How many people here have a smartphone? Don't be bashful. Okay, if you're away from a power port somewhere, USB or AC outlet for 8 hours to 10 hours, does anybody start to get nervous? The moon has no power ports yet. So what we're doing with Astrobotic is making sure that there's plenty of power for everybody, astronauts, robots, to use on the moon.
So some of the progress that we've made so far, this is some actual hardware. This is not just a concept or anything. We're working on this right now, and we have hardware that we're prototyping and going to be testing soon. So later this year, in about July, August timeframe, we're going to be taking this whole system and putting it in a thermal vacuum chamber down at the Johnson Space Center. It's actually the tallest TVAC chamber that you can find in the world. It's the only one that was big enough to hold the whole system and actually deploy it and test it. So once we actually get that test data back, we're going to use that. We're going to get ready for our next lunar mission, and then we're going to build that into our engineering models and flight models that come after that. So you could see some other hardware up here too, some really cool technologies that are on this. We call it the EDS. It stands for the Electrodynamic Dust Shield. And what that is it's just a series of wires, and we can put a current through the actual wires and then brush the dust off the solar array. So this is really, really helpful at locations where we're expecting there to be a lot of lunar dust. If there's a lander landing nearby and there's blast ejecta and it's kicking up dust, and we don't have a way to get that off the ROSA, this is what we do. This is what we put power through the system and then brush the dust right off of it. And then there's another system on here as well that I should call out from NASA. The EDS is developed by NASA, and the UMIC is developed by NASA. That stands for the Ultra Universal Modular Interface Converter. It's a mouthful. But we can use that for distributing power over long distances. So we use this to boost our voltage from 28 volts all the way up to 3 kilovolts. And then we use AC power distribution to send power over long distances. So a lot of really cool critical technologies on here. And I'll probably shift to maybe, I think this is my last slide. And really, this is just what we see as the future of power. So we see that offering power as a service is going to enable missions like Artemis missions, the CLIPS missions, the Commercial Lunar Payload Services missions, which are flying right now, lunar landers that are landing and delivering payloads, instruments to the moon. We also see it for enabling decadal, big science missions. And astronaut utilization, there's really, the possibilities are endless, and we're excited to kind of keep developing that with Redwire and offer it to the community. Thank you.
So Mike, can you tell us a little bit about the power needs that differ from, for example, the habitats and infrastructure built out versus expeditions like science missions might run to the crater or an edge of a crater and so forth? What drives the decisions and how your landers and rovers operate and need power in different locations?
That's a great question. And I think there's a lot of benefits of using the system that we're using. One is because it's mobile. So you can bring power to multiple different locations, distributed access to power. So if you're going to be powering something like a science mission that needs to drive around a lunar crater or go into a permanently shadowed region, we can bring the power grid to that system, and then we can park it at the top of a crater, and then that could power it. Now, if you're talking about human habitats and something that requires maybe a little bit more power than what a science mission might require, we can scale the system up. So Redwire has actually been developing larger solar arrays, and we've been talking about ways to integrate that onto landers or even large rovers to provide, this current system provides 10 kilowatts of power, but we can bump that all the way up to 50 kilowatts and power much, much power intensive applications.
That's awesome. We want to get to a point where power is not a constraint on space. How many people here have ever designed something for space and power was the constraint, the driver? It's a constant pain. We're building now rollout solar arrays similar to what you've seen on the space station that are 60 kilowatts for the PPE, that are that equivalent for lunar surface deployment and chained together to even create a much higher power grid. We should be able to get to the point where we allow hundreds of kilowatts or megawatts of power, even with solar power. So what are the other potential power sources on the lunar surface, and how are those technologies comparable or overlapping with solar power?
Another great question. And I think when a lot of people think about power in space, they think about solar power, they think about nuclear power, and a lot of the times they think about it's one or the other. In our case, we don't think of it that way. We think of they're complementary to each other. There are different applications that require much, much higher demands. And you're talking about, you said megawatts and things like that. That's great for nuclear power. The challenge, though, is that nuclear power is not available right now. This is something that is available right now. This is something that we're building, and we could fly this to the moon in 2 to 3 years and operate it and get enough power for some of the initial science missions that we want to go and pursue, some of the human missions that we want to support with Artemis, and then get us a good stepping stone. So that way we can put these things together. We can hook up a solar power generation node with a nuclear fission power generation node. And now we can have multiple assets in this node that are providing power at different locations.
So you can imagine a day where there's nuclear power along with solar power, maybe back each other up, but also for deployment in different locations as well. Is that right?
Exactly.
So can you tell us a little bit, getting a little bit more technical, but what's the difference in power collection at the mid-latitudes versus the poles of the moon? And what does it mean to have a lunar day, night, and power storage? What does that all look like in your world?
Yeah, the lunar night is like the term we're all afraid of right now. Once a lunar night happens, it gets extremely cold and you need a lot of power to survive. And the only way that you can do that is to power heaters and to keep your system warm. So in our case, when we're talking about lunar night survival, we're talking about a period of 14 Earth days, which is the equivalent of 1 lunar day, and then encountering 14 Earth days again of lunar night. And we need enough power, we need enough heat to survive that environment. So right now, the interest is going to the South Pole, looking around for resources. That's why NASA, that's why commercial companies are interested in developing systems that can operate at polar regions. You'll notice that our array is vertical. So that's because the sun, the incident angle that it's hitting at the South Pole, it's designed to hit that perpendicular to the array. Now, if we were at the equatorial locations, this would be something that we might need to deploy straight out horizontally or maybe on an angle, different applications. But I think right now we're seeing a lot of interest in the poles. So we're really focused at the moment on the polar designs.
That's great. So is this a 2050 type thing, or what are you talking about here? When is this going to be deployed?
I think we could deploy this as soon as 2027. I mean, we have hardware that's developed right now. I think, though, thinking ahead, what does the future look like? I think it's very possible to see multiple of these systems hooked up at multiple different locations on the moon, all connected through cables, just like you'd see like a normal power grid here on Earth. And that we could hook that up with different power assets, nuclear fission power when that's available, so that now when you're operating a mission, you just drive point to point, node to node, get your power, recharge, go off, and now survive multiple lunar days, potentially even years on the lunar surface, which for us is really exciting because I think that's when you start to see a really big return on investment and you see people that it costs still a lot of money to go to the moon and operate on the moon. But if we can spread that cost over several years or even months, it becomes a lot more interesting to groups that want to go there.
Okay. Although we're technologists, oftentimes regulatory and policy are some of the challenges. Anyone here from Europe? Anyone from Europe here? There are a few Europeans here. When I go to Europe, I have to double check all my plugs if they're going to work there or not. And I have to take adapters and pigtails and everything. So what is the process to get standards? How are people going to plug into power, or are they going to be plugging in? Is it all wireless? And what's the standard process there?
Yeah, that is currently, I think, the hot topic in the power part of the industry right now is how is everybody gonna work together to use the same interfaces? And there's different types of interfaces for different needs. You could have wireless power interfaces, which are great for dust intensive applications, because if you have a rover and you want to recharge and it's all dusty and you're trying to align a mechanism and put them together, that's really hard to do. If you have a wireless power interface, you just drive up close to it and get power, just like you put your cell phone on a cell phone charger. That's really interesting. Now, if you're talking about going long distances and you want to have efficient power transfer, cables become really exciting because cables are the way that we always do power here on Earth. And we could lay those out over several kilometers and provide power. Now, trying to get to the point where we have interfaces that are standardized, there's a lot of different discussion groups within NASA and DARPA and other groups right now. They're trying to figure this out. And it's a tough problem to solve because there's a lot of different groups that are competing. We all have competing interests. We all want to make sure that our standards are the ones that are used. But I think what would be helpful is maybe we could start taking it from an approach from a government approach, where maybe they could do like a request for information or a request for proposal and select a few of these interfaces. And then once there's a few of those added to that toolkit, I think they can iterate on that. I think they could add more interfaces that groups can continue to develop, include in that toolkit, if you will, so that there's multiple different standard interfaces. They all have to be evaluated maybe to the same standard, but I think that would be the dream, is if we eventually have multiple interfaces that multiple groups can use, and hopefully driven by NASA or the government.
Okay. Okay, that's awesome. There are a lot of technical aspects to this. I want to go back to one that you mentioned, the lunar regolith. Apollo missions realized that it gets all over everything. It got on their spacesuits and they took it back into the capsule, and they found out it's abrasive and it levitates. It doesn't just sit on the surface, but there's no atmosphere, there's no rain, there's nothing to wash it off. So can you talk a little bit more about how we managed through that with such, and solar panels here on Earth, right? When they get dirty, they lose efficiency and so forth. So just to deep dive a little bit on the technical aspects of how we managed through that, especially with lunar landers and launch vehicles maybe happening within kilometers of a power station.
Yeah, that is a really tough challenge right now. I think there's a lot of research that shows that when landers land, they're going to create these plume ejecta that blast lunar regolith up into space, lunar orbit. And that could be a challenge, because if you have systems like Gateway that are up there and operating and now you have dust floating around, or if you even have systems that you're trying to drive around on the lunar surface and you have astronauts that are operating and walking in that, dust is a big problem, because when dust gets into things like joints, mechanisms, like if you have a rover and it gets into an actuator somewhere in there and it starts to grind up your gears, now you might not have a working wheel anymore. Or if something gets into one of your electronics and it causes like an arcing problem and now your system just faults and you can't operate anymore, that's a really big problem. So there's a lot of different technologies that we're talking about, ways to keep dust out. One of them is what we talked about on our ROSA right now for VSAT, is we're applying the electrodynamic dust shield to just, once we put a current through it, knock the dust right off. There are other things that you can do too, things like seals and dust covers, which need to be maybe a little bit more intricate to keep the dust out. You could do coatings to also put on there to try to just mechanically keep the dust from latching on to the surface. So there's a lot of different things that people are developing right now, and they're all great solutions, all for different applications, but that is a challenge. And I think we need to collect more information. I think once we get more missions that are up there and understanding how dust adheres to things, that we'll have a better understanding of how to deal with it.
That's great. And as an engineer, and for all the technical people out there, I mean, that's one of the kind of challenges of going to the moon, is you're not protected the way you are here on Earth with an atmosphere, magnetic field. You have micrometeorites hitting around you. You have regolith around you, radiation, thermal ranges. So it's an exciting place to be designing things. So just as a wrap up and any final comments, you guys have more missions planned on the moon, to the moon right now, and timing coming up fairly soon. Can you talk a little bit about that, what we should expect and what's exciting for you? What excites you coming around the corner?
Yeah, I love this question. So we have upcoming rover missions. You've seen some of them. We have upcoming lander missions. I think what excites most of us in this industry right now is, what is this future going to look like? And I think we all want to see an ecosystem where there are companies and governments operating on the moon, where we shift from just beyond government demand to commercial demand. And I think once we see this power architecture up there, and once there's a communication architecture, really the building blocks of infrastructure, then we have the luxury to be creative and do the things that we're not even thinking about today. That once you have power and comms and transportation on a regular